if you want to find the instantaneous rate of change at a point, so this expression corresponds to the average rate of change of a function. So if you take h little small values, if you use a little interval, then you can approximate the instantaneous rate of change. So as h goes to 0, as this interval decreases, you find the instantaneous rate of change, which is represented and which is given by f prime of a, and which has a special name, which is called the derivative of the function at that point. Okay, so here the derivative of the function at a point gives us the instantaneous rate of change of the function at that point. And we can define the derivative function. We defined that, in fact, as f prime of x. So this is the derivative function, and this will give us the instantaneous rate of change at any x point. So by plugging in values for x, you can find the instantaneous rate of change. And as we discussed, this corresponds to the slope of a line that is tangent to your graph at that point. So if this is your f function, y equals f of x, the tangent has slope f prime. So here it is at that point a, f prime of a. Okay, so these are like the ideas we discussed so far. Today, in fact, we will see an example of this. So what does it mean is that if you want to find the function value at a plus h, so let's say you want to find the function value at a plus h, what you can do is you can just make use of f of a. So this is f of a, right? The y value at a. And you can just add to this the rate of change at a times how much the x is changing. Because, just look at this formula that we discussed, because the derivative corresponds to the slope, okay, so the slope of that line that is tangent at a corresponds to the derivative. So we can just approximately say that the derivative at a equals to this average rate of change. So if you don't take the limit, you can say this is still approximately equal. If you take the limit, they are exactly equal. But if you say the without the limit, it is approximately equal. And if you just solve this equation for f of a plus h, you will find this equation. So that means to be able to predict, be able to find the value of the function at a plus h, so this is f of a plus h, you can make use of this tangent line. Just use the value at a, f of a, and add to that value the rate of change plus, times how much you are moving. Okay, so we will now see an example of this type, population change. So let's first see how we define the population. So we use a function, let's say p of t, that is the number of entities present in a population. So number of people, let's say, or you can talk about number of bacteria in an experimental population. And p of t represents the amount of population at time t. So the population growth rate of pt is defined to be p prime. So the derivative of p will tell us how much this population is changing. Is the population increasing? Is it decreasing? So this is going to be determined. How much the population is changing is determined by the derivative. Okay, so let's look at this example. The population of a city is tripling every 5 years. If the current population is 10,000, we would like to know the population in 2 years from now. So we will approximate the population in 2 years from now. Let's consider the population. So how do we write the current population? So when we talk about the value of the population now, how can we denote it in terms of the p function? So let the population be denoted by the p of t function. So if the current population is 10,000, we can say that p of 0 equals 10,000. Okay, so the current population is 10,000. This is the beginning value. This is the initial values. So the current means we take time equals 0. So in 5 years, because it is tripling, we can just say the population in 5 years. What do you expect the population be in 5 years? It has to be 30,000. So the population will be 30,000 in 5 years. So we can approximate the rate of change of the population. Okay, so remember the derivative will be the rate of change by comparing these two values. So it's going to be the difference between the population at after 5 years, and so we are just finding the average rate of change. So the population after 5 years, population now, divided by the time that passes after 5 years and now. Okay, so we just find f of x here, f of x plus h minus f of x, just compare it with this formula, divided by h. Okay, so in 5 years, the difference will be just 5. Okay, so 5 years. And the population, how much is it going to change? It's going to become 30,000. And the current population, P of 0, is 10,000. Okay, so what do we find? We find 20,000 over 5 as the rate of change. So every 5 years, sorry, in fact, each year, let's divide it. So we divide it by 5, we have 4,000. Okay, so this is in fact the rate of change. Every year, it's going to increase 4,000. So in 2 years, it's going to increase twice this amount. So to let me write the formula that we were given, I mean, in the book. I will show you in a minute. So to find, what are we looking for? We want to find the population in 2 years. Okay, this is the question. And how can we find it? Just use the current population plus add to this the rate of change of the population times h, how much time there is until that point. Okay, so let me just show you here. So this is the average rate of change. Which corresponds to the derivative approximately, right? And we had said that if we want to find the value at a later time, at a different x value, we can make use of the current value, which is this one, plus the derivative of the function at a, times h. So this was the formula we had in the book. I had just went over that expression, that equation, and we said that this is approximate. So this approximates, okay? Because the derivative equals to the limit of this expression. And if you don't take the limit, you can just use the average rate of change for an approximate value. Okay, so if you come back to this question, we know that the population triples every 5 years. So from this time on, after 5 years, the rate of, the change in the population will be 20,000. And if you divide it to 5, divided by 5, you will find 4,000. So every year it's going to increase 4,000. So if we plug it into this formula, so we just use this formula and write it for our function. So P of 2, the population in 2 years, can be found by the value at like the initial point at 0, and add to this 2 times. So we want to find it after 2 years, the rate of change. Okay, so P of 0 was 10,000 plus the rate of change is 4,000 times 2. So what's going to be the population? The approximately, it's going to be equal to 18,000 in 2 years. So there's another assignment, and the answer is at the back of the book. You can just practice that. And I also assigned similar problems on my Open Math, so you can work those out in a similar way. Okay. Let me see. There are also a few problems where tables are used. So I don't see an example of those in the textbook, but I think those are also helpful. So maybe I'll just show you from my Open Math. Okay, so in fact, question 2 is an example. So this chart shows the living wage jobs in Rochester for 100 working age adults over a 5-year period. Okay, so the year and jobs, like number of jobs, are shown. What is the average rate of change in the number of jobs from 97 to 99? So from 97 to 99, how would you find the average rate of change? So what is average rate of change? We find the difference in y's. Let me just say, just the slope formula. In short, you can just make use of the slope formula between 2 time points. So in this case, in year 1997, the jobs number of jobs were 675. So from 1997 to 1999, we will compare how much the jobs changed. So be careful. You can change the order of x's, but I prefer to have the larger one in front so that the answer is positive. And when you write the y values, the output values, you should just stick to the same order. So during 1999, what was the y value? So during 1999, the number of jobs was 770. And during 1997, the number of jobs was 675. The average rate of change in jobs between these 2 years, 770 minus 75, which is 95, over 2, which is 42.5. Okay, so this is, I don't know how this menu keeps popping up. Oops, sorry, I think I divided wrong. So like 95, yeah, that's right. 95.2 will be 47.5, not 42.5, sorry. So this is how you can find the average rate of change, and just compare 2 time points. You can do it for this question as well, and you can do the same for these other questions. And when you talk about the instantaneous rate of change, then you would need to consider the two time intervals that are getting close to each other that would correspond to the derivative of the function. So we talked about rate of change, and we related it with derivative.